This video is about electrodes. The important electrodes covered in this video are reference electrodes and reversible electrodes. Reference electrodes are simple hydrogen electrodes, Kilometer electrodes, and one of the secondary reference electrode coming under Redox Electrode category is quinhydron electrode. And the reversible electrodes covered in this video are metal ion electrodes, metal insoluble metal electrodes, and the gas electrodes. Actually, it is difficult to find out the electrode potential of an individual half cell. Only we can calculate the difference in electrode potential of two half cells. So we can calculate the difference in electrode potential. That means we are calculating the relative electrode potential of half cells or electrochemical cells. Relative electrode potential. And the electrodes which we are used to find out the relative electrode potential of a half cell or an electrochemical cell is known as reference electrodes. So we are connecting our half cell with the reference electrode and we can calculate the relative electrode potential of this half cell. One of the important reference electrode is standard hydrogen electrode or SHE. Standard hydrogen electrode consists of platinum rod coated with the platinum black, which is immersed in acidic solution, that is immersed in H plus ions, and the pure hydrogen gas is bubbled through this H2 gas at 1 atm pressure. So this is the construction of a standard hydrogen electrode or normal hydrogen electrode. Here the concentration of the H plus ions or the acidic solution used as the electrolyte is 1 molar. And the concentration of the reduced species and the oxidized species is maintained at unity. Here the cell may act as anode or as cathode. So if it is act as an anode, that is when it is attached to a cathodic half cell, the cell can be represented as platinum H2 gas at 1 atm bar H plus and molarity is 1 molar. And this standard hydrogen electrode acts as an anode. We know anodic reaction is oxidation. So H2 converts to H plus plus 2 electron, here 2. So H2 is converted to 2H plus plus 2 electron. On the other hand, if it is act as a cathode, then the cell can be represented as H plus 1 molar bar H2 gas 1 atm platinum. And the cell reaction is reduction reaction, that means H plus 2H plus 2 electron gives H2. This is the anodic and cathodic reactions of standard hydrogen electrode. Actually, this standard hydrogen electrode have a particular electrode potential. For our convenience, we are fixing the electrode potential of standard hydrogen electrode as 0. So we are considering that electrode potential of She is 0. So when we combine this with another half cell, the net electrode potential of the cell is considered as the single electrode potential of the half cell, of the second half cell. Okay. Next one is Kilometer electrode. Kilometer electrode consists a wide glass tube containing a narrow side tube and a platinum electrode is there. So a platinum electrode is there, which is dipped in mercury covered with mercurous chloride. So it consists a wide glass tube containing a narrow side tube, and a platinum rod is dipped into mercury covered with mercurous chloride. This is mercury Hg2Cl2, and this white tube is filled with a KCl solution. Here also KCl solution. So this is the basic construction of a Kilometer electrode. Actually, Kilometer electrode is classified as a secondary reference electrode. Secondary reference electrode. Normally, in experiments, we use Kilometer electrode as a reference electrode because the standard hydrogen electrode is difficult to maintain. So we require a simple reference electrode. That is why we use Kilometer electrode. So first of all, we have to find out the individual electrode potential of this Kilometer electrode. So here, what we are doing is, we have to pair this Kilometer electrode with standard hydrogen electrode, and then we have to find out the individual electrode potential of Kilometer electrode. After finding out its individual electrode potential, we can use it as a reference electrode. That is why it is classified as secondary reference electrode. Normally, the individual electrode potential of Kilometer electrode depends the concentration of KCl. Here, KCl is actually used as a salt bridge between the Kilometer electrode and the second half cell we are using. But the electrode potential depends its concentration. So, if we use 1 molar KCl, then the electrode potential is found to be 0.28 volt. If we are using saturated KCl solution, then the value is measured as 0.242 volt. Okay. So the important characteristic of Kilometer electrode is it can maintain its voltage, constant voltage for a long time. So can retain constant voltage for a long time. Then if you talk about the reaction of Kilometer electrode, it will be like this. Hg2Cl2 reduced, that is gain 2 electron and converts to Hg plus 2Cl minus. So this is the basic reaction of Kilometer electrode. Here the Kilometer electrode can be represented like this. Cl minus bar Hg2Cl2 Hg. So this is the cell representation of Kilometer electrode. And the next reference electrode is quinhydron electrode. This is also a secondary electrode, secondary reference electrode. And the potential of quinhydron electrode is measured as 0.2875 volt at 298 Kelvin. So it consists a glass tube containing quinhydron, in a specific H plus concentration. Then a platinum electrode immersed into the quinhydron. And the platinum electrode immersed in quinhydron helps to acquire a potential. So this is the basic construction of a quinhydron electrode. Actually, quinhydron is an equilibrium mixture of quinone and hydroquinone. Quinone and hydroquinone. So quinone is a cyclodicarbonyl compound, and the quinhydron is this OH. Two hydroxyl groups are there. This is quinone and this is quinhydron. So the reaction is actually like this. Quinone will abstract 2 hydrogen ions and 2 electron and converts to quinhydron. So actually this is a redox reaction. So redox reaction between quinone and hydroquinone, and this type of electrodes are actually classified as redox electrodes. So redox electrode means oxidation reduction reaction take place in between the same species. So when quinone reduced, it converts to quinhydron, and so in these type of electrodes, that is redox electrodes, the potential is developed by the change in oxidation state of the same species. Here in quinhydron electrode, the potential is developed because of the change in oxidation state of quinone and hydroquinone. So the basic reaction, oxidation reduction reaction, is this. If we simply represent quinone as Q and quinhydron as QH2, then we can simply represent the cell as platinum bar quinhydron, quinone and H plus. So this is the cell representation of quinhydron electrode. Here we learn a new electrode called redox electrode, right? Redox electrode means the electrodes in which potential developed because of the presence of ions of same substance, having different oxidation state. So we can define redox electrodes as electrodes in which potential developed because of the presence of the ions of same substance having different oxidation state. One of the important example which we can use as a reference electrode is quinhydron, right? So quinhydron electrode is an example of redox electrode. Quinhydron electrode. So if we construct a redox electrode of iron, we can write the relation like this. Iron Fe2 plus will convert to Fe3 plus by releasing one electron. And if you are writing the relation of tin 4 plus, the reaction will be like this. Tin 4 plus 2 electron will give tin 2 plus. Same way we can construct redox electrodes of different metals. Then moving on to the next type of electrode, that is reversible electrodes. Reversible electrode means the electrodes in which reactions exist in an equilibrium. Reactions exist in an equilibrium state is known as reversible electrodes. The first type of reversible electrode is metal ion electrode. Metal ion electrode. So in this electrode, a metal rod is dipped in an electrolyte containing the same ions. For example, if you are dipping zinc rod in an electrolyte, the electrolyte should contain Zn2 plus ions. For example, zinc rod dipped in zinc sulfate solution is an example of metal ion electrode. And the copper rod dipped in copper sulfate solution, CuSO4, is also an example of metal ion electrode. So generally we can say metal rod M dipped in a solution, an electrolyte containing Mn plus, then it can be classified as metal ion electrode. So this can be act as an anode as well as a cathode. If it is an anode, then oxidation reaction will take place, and the general reaction can be written like this. M will be converted to Mn plus N electron. Okay. If it is a cathode, if it is act as a cathode, then the reaction will be reduction reaction. We can write it as Mn plus N electron reversibly gives M. So combinedly we can write the reaction like this. M reversibly gives N plus N electron. Okay. So if it is act as an anode, reaction shift towards right, and the concentration of N plus ions will be increases. If it is act as a cathode, then the reaction shift backwards. This reaction will occur and the concentration of Mn plus ions will be decreased. Each half cells in a Daniell cell is an example of metal ion electrode. The second type of reversible electrode is metal insoluble metal salt electrode. Insoluble metal salt electrode. Here the metal along with metal insoluble salt is dipped in metal soluble salt. So particular here this is metal insoluble salt, and this is soluble salt. A typical example of this metal insoluble metal salt electrode is Kilometer electrode. That is Hg in HgCl2 is dipped in a soluble salt KCl. Right. So, and another example of metal insoluble metal salt electrode is silver electrode. That is the cell can be represented like this. Ag in AgCl is dipped in Cl minus. Then the third type of reversible electrode is gas electrodes. Here a suitable gas is bubbled through a solution at a constant pressure, and a suitable metal rod is also used in this type of electrodes to develop potential. So usually used metal rod is platinum. The best example is hydrogen electrode. And chlorine electrode is also an example of gas electrode, chlorine electrode. And the reaction is like this: half Cl2 plus electron reversibly gives Cl minus aqueous. And the cell can be represented like this: platinum Cl2 gas bar Cl minus aqueous.